All right, hey guys, we have another lesson video to do. Congrats, you made it to inverse functions. We did unit 1, on to unit 2 now, hitting the ground running. So you guys were focusing on composite functions during class. Maybe some of you got to the inverse functions, but I wanted to make sure you had all the resources to be successful. So talking about inverse functions, we first need to kind of go over what a function means again. So just real quick, we know that we start off with some x, we put it into some function f of x, and then out pops our y value. And so we've always done this. We can do the example f of x is equal to x squared plus 3. And so if we're looking at x squared plus 3, maybe we want to plug in an x equal to 2 into this situation. So we go through our steps. We know, all right, well, if x equals 2, then our function machine is telling us that we need to plug in a 2 here. So 2 squared plus 3, or 4 plus 3. So out comes our 7. So when we input an x equals 2, we get an output of y equals 7. But one thing we've never really talked about is, well, what about the other way? What if we start off with a 7 and we want to get back to a 2? How do we do that? So that's kind of where inverse functions come in. If we want to find an inverse of this, we need to figure out another function that can take a 7 now, runs through the process in reverse and gets us an x equal to 2. So you can think of the inverse function as kind of the reverse of our original function. So the way we can actually do that, so an inverse function in terms of this is just telling us what function will take our output and spit out our input. So let's take a look at f of x again. X squared equals f of x equals x squared plus 3. I'm going to ditch the blue. It looks like it's really light. I'm sorry, guys. Let's go to the red. So if we have, so let's say finding the inverse. So if we have our function f of x equals x squared plus 3, well, we know if we put in a value here, we'll get out a value here. But we want to do the opposite. We want to put in a value in place of f of x and find the right value so that our output becomes that 2. In the case of putting a 7 in place of our f of x. So it's a little easier to kind of see this in terms of y. I like to switch it out. And then what we're going to do here is actually solve for x. So our first step was swap f of x with y. And now we're going to solve for x because we now want our new output to be what our original input was. So this is all in terms of our original function. So we look at this, we notice, hey, we have a plus 3 going on here, so we want to subtract 3 from both sides. So here we get y minus 3 equal to x squared. Finally, to solve for this x, we just take the square root of both sides. These cancel, and what we find is that our x is equal to the square root of y minus 3. So step 2, solve for x. Our step 3 is really just a notation thing. We want to show that this inverse is a function of itself. So the general notation is that x means input, f of x means output. So just to follow those conventions, we're going to swap. So step 3, swap x for f of x and y for x. So our final function becomes f inverse of x, that's what the -1 up here means, is going to be equal to the square root of x minus 3. So that's all there is to it. And what we're going to do now is actually check this out. So if we do a check on this, if we're looking at the above function and we want it to reverse the process, we hope that this function will take in a 7 and give us a 2 out. So let's check that. X equals 7. That means our inverse of our function is going to be the square root of 7 minus 3, which equals the square root of 4. And look at that, we get an output equal to 2. So it reverses this process. So one way we can actually check that this works for any value is looking at the official term for it. So the inverse functions can also be shown as saying the composition of f of g of x. So f of g of x should equal x. Focus that for y'all. And then we also need to check the other way. G of f of x should also pop out to be x. Uh-oh, running out of ink. Okay. So we're checking these two things. We want to make sure we have our two functions again. So our first one that we're going to check is x squared plus 3. And then we have our g of x equal to the square root of x minus 3. So if I can put this one into here and I can put this one into here and we get x's in both cases, then we have inverse functions. So let's do this. We are starting with our f of g of x. So anytime we saw an x, we're going to replace it with what g of x represents, the square root of x minus 3. So here we see that this mystery square is now our g of x. So we got the square root of x minus 3 squared, and then we're adding 3 to it. So we square a square root. We will see that it comes out to x minus 3 plus 3 or x. So far so good. We got one way done. Now let's try the g of f of x. So now we're putting our f of x function inside of our g of x function. So we're going to have a big square root going on, and we know we need to replace this x with the x squared plus 3. So we've got x squared plus 3, and then we're subtracting 3 off that, and hopefully we'll find that this simplifies down to x. So 3 minus 3 cancel, and we get the square root of x squared, which also equals x. So that means that these two are inverses of each other. We found it through our machine. We found in our specific value. Now we did it for all values. The last way we can do this is actually looking at the graphs of the two. So I guess I'm going to do my graph in red because this is kind of hard to see the gray. So last we can see it graphically. And the two functions will be reflections over y equals x, over the line y equals x. So if we're checking this out, we can make our graph so. So we know y equals x is going to be a constant rise over run. So 1, 2, 3, 4, 5, 6, 7, 8. That should be good. 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. Okay. So we have our y equals x line, we have x and y, and we want to graph these two guys. So for x squared plus 3 has its vertex at 3, and it goes off like so. I'm going to do a dashed line like this just to show you one thing. So then the next one is our square root of x minus 3, our g of x. So this is our f of x. Oops. It's going to be purple now. X squared plus 3, and our g of x, sorry guys, it's just going to be reversed, starts at 3 and then makes its way up like this. So this is our g of x, which is equal to the square root of x minus 3 dot inverse. So notice how this is actually a reflection over the x-axis. This distance right here is the same as this distance right here, which is the same distance as this right here, which is the same distance right here. So one thing to show is that there's specific domains or specific x values where you actually have this inverse. So notice right here, if we tried to have negative values, we're not going to have any inverses. And we have to look at this value right here. We cannot have any outputs of this that is a negative number, and remember the outputs coordinate to the inputs. So if we have x to f of x, that's almost saying the input is now the output is now the input. So if we say started out with a -2, well, that's great. -2 squared is 4 plus 3 is 7. But if we're trying to start off with a 7 and get to a negative number, well, 7 minus 3 is just going to give us a positive 2. So notice how we actually don't get the negative values. So sometimes you're going to have inverses or functions that are only inverses for certain parts or for certain domains.